So this is question 5. You're given a differential equation and then you're given your initial condition. You're told to find the particular solution, that is, of this initial value problem, and then the largest interval over which the solution you obtain is defined on, that is the interval of definition. So let's start by finding the general solution of this differential equation. Now the first thing is, before I begin to start solving this, you should note that this is a linear equation. A linear equation in x now, not y. So since it's a linear equation in x, it's going to help me in recognizing fast that I could use the integrating factor method to solve this linear equation here. So now what we have is, or what we are given is y, the x, the y minus x equals 2y squared. So to use the integrating factor method, the first step I need to do is to rewrite this whole differential equation in standard form. So rewriting in standard form simply means that the coefficient of the derivative here should be 1. So to make the coefficient of that derivative to be 1, I have to divide both sides by y. So what I'm going to have is, you have the x, the y minus 1 all over y, x equals 2y. Now, having done this, the next thing is we recognize that this is going to be the power of e, which we're going to use as our integrating factor. So you recall that the integrating factor is e to the power negative 1 all over y dy, and this is going to be e to the power negative ln of y, so which is equal to 1 over y. So having gotten the integrating factor, we multiply both sides of this differential equation by the integrating factor, which is 1 all over y. So what we have is 1 all over y, the x, the y, minus 1 all over y squared times x equals 2. So this could be rewritten using product rule as d dy into 1 all over y times x then equals 2. So trying to solve this, so we integrate both sides with respect to y. So this is x all over y dy equals the integral of 2 dy. So let me write my y very well. So what we now have is, so it's like you're integrating a derivative, so you're still going to get the same thing. That's going to be x all over y equals 2y plus my arbitrary constant. So my x equals 2y squared plus ky. Now to use the initial condition I'm given, it says when x is 1, my y is 5. So this is going to be 2 times 5 squared is 25 times 2. That is 50 plus k times 5. So to find k, you have 40. This is going to be negative 49 equals 5k. So which implies that my k equals negative 49 all over 5. So I've been able to find my x. So using this, because this is the general solution, so my x equals 2y squared minus 49 all over 5y. Now this is the particular solution of the initial value problem that we're given. Now the next thing we're told is to find the interval of definition. So the interval of definition actually is this. This is where we'll be looking at to find the interval of definition here. The standard form of the differential equation actually in x now. So in x, the interval of definition of this, now looking at this, what we have here is going to be valid for all values of, because these are the main men here. So looking at this one here, the denominator here must not be 0. So you either choose for your y now, your y has to range in all real numbers except 0. So you could choose any of them. So what I'm going to go for this now. So if my y ranges in 0 to infinity, so when y equals 0 now, when y is 0, my x is just going to be 2 times 0, that is 0, minus 0, that will be 0. And when y equals this large number, which is infinity, so since this has a power of y squared, so it simply implies that this is the leading term. So when you substitute y equals infinity here, you permit me to use that word, so you're still going to have, so when y is, you actually cannot just substitute, you meant to take the limit as something tends to that, but for simplicity, let's assume when y equals infinity, we know that x is going to be this. So with this paradigm, we could just say that the interval of definition is 0, infinity. So this is our interval of definition actually. So it should help in doing that. Any questions you have, you could just drop them down below the comments.